Today, we will be observing the squeeze casting process, the manufacturing process that proves even metal can handle pressure better than you during finals week. We begin this process by melting down aluminum at high temperature. Once the aluminum is melted, the furnace is capped with an argon mixer. Inert gas is pumped through the center of this mixer into the molten aluminum, which displaces the oxygen inside the cask. This helps to purify the aluminum. Once all of the impurities float to the top, they're skimmed off. The pure molten metal is then loaded in the transfer casks. From here, it is loaded into machine hoppers where it is kept at temperature until it's time to make the final parts. This process may look like traditional die casting so far, but the similarities will end soon. The metal is injected into the mold using a large pipette with sub-gram accuracy. In this video, the aluminum is injected into a runner which plunges into the mold to remove void space. Right as the metal begins to solidify, we hit it with a hydraulic press. Instantaneous pressure like a thermo tube pop quiz. This step mimics the forging process where a die is squeezed tightly around the molten metal. Squeeze casted parts are stronger than die cast parts, as the high pressure forging process of squeeze casting fills voids, eliminates porosity, and increases strength of the part. Squeeze casting is used to make high performance parts for automotive and aviation applications, as well as that janky lab machine that costs more than your tuition and breaks if you look at it wrong. At this point, the part is as poorly dressed as a late night Walmart shopper. The part is then inspected, machined, and surface treated to improve its appearance. Squeeze casting transforms molten metal into something strong and useful, kind of like what your professor thinks you're going to become after you graduate.